Yes, sir.
Okay. Yesterday I forgot to record the lecture, okay. But I have sent you the one lecture from our other batch, okay. But yesterday I forgot to record. Can you guys see my notebook also?
Yes, sir.
Okay. Okay, so one thing is that if some of you are new to this group, then apart from this Zoom link, we also have Google Classroom. Do you guys have link to this Google Classroom, everyone? If anyone don't have the link, please let me know, or you can email me. You can send me an email if anyone of you don't have access to this Google Classroom. So all of you have access? Okay. Then it's fine. Okay. And please send me an email. Okay. From this chat, I will not remember. Please send me an email to my ID, to this email ID. tghosh@rgipt.ac.in. Please send me an email to this email. Okay. Then I'll add you to Google Classroom.
सर आपने कुछ असाइनमेंट दिया था?
No, I gave you tutorials. Tutorials are the problem set for you to practice. And if you guys face any trouble in solving those, then I'll discuss on Thursday. But those you don't have to submit me the answers. Okay?
सर वो करके सबमिट नहीं करना है?
No, you don't have to submit. You don't have to submit. If you have any trouble, then you can discuss with me on Thursday. Assignments, I'll mark those assignments and I'll also tell you the deadline. Deadlines usually is the Friday. Okay. For example, I'll give you some assignment this week, and by next Friday you have to submit those assignments. Okay. No, we have not had any tutorial class yet. Tutorial will be on Thursday. Last week, Thursday was a holiday. So we have not had any tutorial class yet. This week we'll have a tutorial class. Okay, any other question regarding the class? Okay, if not, then let me recap again. I'll try to explain this spherical and the cylindrical coordinate briefly again. Yesterday we hurried a little bit, but I'll explain again how to attach these coordinates. Okay. So basically we learned about different coordinate systems, plane polar coordinate, spherical polar coordinate, and cylindrical coordinate system in the previous lecture. So for spherical polar coordinate, so I told you that for spherical polar coordinate, you need to imagine a sphere, a three-dimensional sphere, a sphere or a circle, right? And then let's say at the center, we have this is a Cartesian coordinate system, let's say. This is the Cartesian coordinate system, X, Y, and Z. So then any point P on this, let's say this point P, this you can mark by, this you can denote by this Cartesian coordinate system, and its coordinate will be then P, X, Y, Z in Cartesian system. This is in Cartesian coordinate system. But at the same time, I told you that you can assign a spherical polar coordinate. that in spherical polar coordinate, this will be r, theta, and phi. This will be in spherical polar coordinate. So what are r, theta, phi? That we define r. R is the distance of this point P from origin. This is distance r. And theta is this angle from the z axis, and this we call the polar angle. And what is phi? For phi, we need to make a projection. This is the projection on the xy plane. This is the projection on the xy plane, and then this angle is called phi, right? And this one is r sine theta, because this is r and its projection on the xy plane will be r sine theta. And then you can write what is x. X is basically this distance is x, right? Then this x will be r sine theta cos phi. Y will be r sine theta sine phi. And z will be r cos theta. Z will be r cos theta. So these are the basic conversion. And then I also told you the unit vectors. Unit vectors are along the r direction. This is ER. Along the theta direction. These are the basic conversion. And then I also told you the unit vectors. Please, whose speaker is this? Please mute yourself. Please mute yourself. And this direction will be direction of E phi cap. And I also gave you the expression for this unit vector ER, E theta, and E phi. And today I'll give you a generalized formula so that you can derive this expression for ER cap, E theta cap, and E phi cap. And I also told you to work out this expression gradient of T, how it looks like for in the spherical polar coordinate, and also this expression divergence of A, curl of A, to work out this example from the partial derivative, if possible. Okay, so this is one example, and second example that we gave example of cylindrical coordinate. We gave you this example of a cylindrical coordinate system that is attached to a that you can attach on a cylinder surface. Let's say this is your cylinder. Let's say this is the cylinder, and at the base we can attach a coordinate system again. This will be your Cartesian system x, y, and z. This is the normal Cartesian coordinate system. And then if we want to represent any point P on the cylinder surface, let's say this point P, how we can represent this point P? So in terms of the Cartesian system, we can represent this as a P, X, Y, Z. That is in the Cartesian system. That is in Cartesian coordinate. But in cylindrical coordinate system, we'll represent this in rho, phi, and Z. That is in cylindrical system. So what are rho, phi, Z? So what is Z? Z basically is this vertical distance. This vertical distance, this is Z. And what is rho? Rho is the distance of this point P from Z axis. So what is the distance? Please, I'll mute everyone. If you guys don't mute yourself, I'll mute everyone. Darshan, who is this guy? Please keep yourself in mute mode, everyone. Otherwise, I'll mute everyone myself. Okay. Okay, and So this is z, this vertical distance is z, and rho is the distance of this point P from this z axis. This distance is rho. This distance is rho, and this angle is phi. This angle is phi. Okay. So this is rho phi z, and what are the conversion? Then this is x. This distance is x. So what is x? X will be rho cos phi. Rho cos phi. Okay, let's write in next page. Okay. So x will be rho cos phi, y equal to rho sin phi, and z is basically z. And the unit vectors. So for the z direction, this will be same E z cap, and rho is basically tangent to the curved surface. So E rho cap will be along this direction, and E phi cap. Sorry, this is E phi cap. This is not. This is E phi cap, and rho cap is outward from the z axis. So this is E rho cap. And then again, I also gave you the expression for the unit vectors and told you to work out this formula for gradient of T, divergence of A, and curl of A. These three expressions. Okay. Okay, is this part clear to everyone? How we are describing this coordinate system? Okay, so these, as you can see, these are not linear coordinates. The straight line coordinates are basically in the Cartesian system. But in this spherical polar coordinate, in this spherical polar or in cylindrical coordinate system, these surfaces are not straight line. These are example of curvilinear coordinate system. These are called curvilinear coordinate system. These are called curvilinear coordinate system. And also we told you that the unit vectors are perpendicular. For example, E r cap dot E theta cap, that is 0, or E r cap dot E phi cap, that is 0, or E theta cap dot E phi cap, that is also 0 in spherical polar coordinate. Also in cylindrical system, we told you that E rho cap dot E phi cap, that is 0, E rho cap dot E z cap, that is 0, and E phi cap dot E z cap, that is 0. That means these are orthogonal. So we'll only study only one subset of this curvilinear coordinate system. Those are orthogonal. There can be coordinate system which are not orthogonal, but we'll study only this orthogonal curvilinear coordinate system. Okay, and so in this class we'll basically try to formulate a general description how to determine these unit vectors and this formula for this gradient divergence and curl, and also how to represent this volume element and the infinitesimal displacement. Okay, so let's formulate a general description for this system, this curvilinear coordinate. So generally how we can represent? So let's say this is the normal Cartesian system. This is a 3D Cartesian system, X, Y, and Z. Okay. Then let's say we have a point P here. Okay. And then we can attach we can represent this point P by some other coordinate system also. Let's represent by this curvilinear coordinate system, which is represented like this. This is general. Okay, these curves are general curve. You can draw in any other way also, but in most book these are drawn by like this, so I am also drawing like this. Okay, so this is U2, this is U3. So as you can see, this x-axis, y-axis, z-axis, these are straight line. But this coordinate system, U1, U2, and U3, here the coordinate axes are not linear. These are curved coordinate. Okay. So now we can represent this point P in the Cartesian system. This point P will be represented by this coordinate P, X, Y, and Z. But in this new coordinate system, this U1, U2, U3, this curvilinear coordinate system, we can again represent this point P by these coordinates U1, U2, U3 by some values of U1, U2, and U3. We don't know. These are some arbitrary values of U1, U2, and U3. So our goal is to determine the unit vectors for this arbitrary curvilinear coordinate system. So how we'll determine the unit vectors? So let's start with this Cartesian coordinate system. So how we define the this I cap along x, j cap along y axis, or I cap along x axis? How we define this unit vectors in Cartesian system? So I cap is basically, you can say I cap is basically del r. R is the position vector divided by del x, and then mod r by del x. I'll tell you what I mean here. So r is the position vector for this point P. R is the position vector x I cap plus y j cap plus z k cap, right, in the Cartesian system. Now what is del r by del x? Del r by del x is basically I cap. And if you take the mod of del r by del x, that is again 1, right? So you can see this, you can define these unit vectors if you do this derivative. What is del r by del x? That is basically tangent to the curve r, right? This is the position vector for this point P. So del r by del x is basically tangent to the curve. We have learned in the first class. So that is the tangent to the curve. And if you take a unit tangent, that basically represent the normal. That represent the unit tangent we defined in the first class. So we can represent I cap like this, del r del x by mod of del r del x. Okay, so this is del r by del x. Now, so similarly, we can define these unit vectors in the curvilinear coordinate system also. Let's say along E1 direction, our unit vectors is E1 cap, okay. Along U2 direction, our unit vector is U2, E2, and along U3 direction, our unit vectors is E3 cap, okay. So how we define E1 cap then? E1 cap is basically del r by del U1 divided by mod of del r by del U1. Similarly, E2 cap, this is defined as del r by del U2 defined it by del r by del U2. And again, what will be E3? E3 will be del r by del U3 divided by mod of del r by del U3. Okay, so this E1, E2, E3 are the tangent unit vectors. E1 cap, E2 cap, E3 cap, these are the unit vectors. These are the unit vectors. Okay. And also, these are orthogonal. These are orthogonal. E1 cap dot E2 cap is equal to 0. E1 cap dot E3 cap, this will be 0. And E2 cap dot E3 cap, this will be 0. That means this is orthogonal curvilinear coordinate. Okay. So how we are defining? We are defining just in terms of their position vectors, the del r del U1 by mod of del r del U1 for E1 cap. Similarly, we are defining this for E2 cap, as similarly for E3 cap. Okay. So let's little bit simplify this expression. Okay. So I told you that E1 cap, that is del r by del U1 divided by mod of del r by del U1. And this we can write del r by del U, that is equal to H1 E1 cap. Okay. What is H1? H1 is basically mod of del R by del U. Okay. Similarly, you can write del R by del U2 equal to H2 E2 cap and del R by del U3. This will be equal to H3 E3 cap, where H2 is mod of del R by del U2 and H3, this is equal to mod R by del R by del U3. Okay, these are vectors. Okay, R are vector. Okay, and what is H1, H2, H3? These are called scale factor. H1, H2, H3, these are called scale factor. These are called scale factor. So you can see in case of Cartesian coordinate system, the scale factor is 1 because mod of del R del X is 1. But this can have any values other than 1 as well for a coordinate system. In 3D Cartesian coordinate system, all the scale factors values are 1. We can take an example of cylindrical coordinate system, and then you can see these scale factors values can have values other than 1 as well. Okay, so let's try to do this cylindrical coordinate system in terms of this generalized formula. So this will be clear to you. Okay, then. Okay, so in case of cylindrical coordinate system, what we told you? In case of cylindrical system, we told you that x equal to rho cos phi, y equal to rho sin phi, and z equal to z. Then the position vector r, this we know x I cap plus y j cap plus z k cap. So we can write this as rho cos phi I cap plus rho sin phi j cap plus z k cap. Okay. So now if we want to find out the scale factor, H1 means del R by del U1. So what are U1, U2, U3 here? So here U1 is basically rho, U2 is basically our phi, and U3 is basically our z, right? And now if we want to find out the scale factors, so what is H1? H1 is basically del R by del U1 and its mod. So what will be this value? Okay, so what is del R by del U1 then? Here in our case, here del R by del U1 here, this is equal to del R by del rho because U1 is rho, right? So what is del R by del rho? This is R. This is the expression for R. So what is del R by del rho? So this will be rho sin phi this will be what will be del R by del rho? That will be I cap cos phi plus j cap sin phi, right? Is this clear? Okay, so this is del R by del rho. And then what is the mod of del R by del rho? Then mod of del R by del U1 equal to mod of del R by del rho. This is equal to cos square phi plus sin square phi. So this is basically 1. So in our case, this cylindrical coordinate system that you can see, this H1 is basically H rho, that value is 1. Similarly, you can find out H2, that will be basically H phi. So that will be del R by del phi divided by mod of del R by del phi. And this you can do. What will be del R by del phi? Del R by del phi, that will be, you have to do derivative. This will be minus rho sin phi I cap plus rho cos phi j cap. So this will be minus rho sin phi I cap plus rho cos phi j cap. And what is mod del R by del phi? This will be mod of rho square sin square phi plus rho square cos square phi. So this will be rho. So you can see the scale factor here, H rho, that is H phi, del R by del phi, that is not 1, that is rho. The value of the scale factor along this E phi coordinate, that is not 1, that is rho. Similarly, you can do it, this expression for Hz also. That will be del R by del Z divided by mod of del R by del Z. You can verify this will be 1 as well. So you can see in cylindrical coordinate system, our scale factors is H rho is 1, H phi is rho, and Hz equal to 1. And you have already got the expression for the unit vectors as well, right? By doing this, because you know what is del R by del U1. This is this, and divided by del R by del.
The screen not visible.
Yes, just one. Yes. What happened? Okay, so we lost Wi-Fi connection. So let's get this connection again. So let's here. Okay, so apparently we lost the Wi-Fi connection. So let me connect to this Wi-Fi again. So, you guys can hear me, right?
Yes, sir, you are audible.
Okay, only the screen is not available. Okay,
Yes, sir.
okay. Let me get. Um, it's only showing this one. Let me try. No, it's still not available, right? The screen you can't see.
No, sir.
Mhm. Uh, I don't know why suddenly it stopped. So let me try this one. No. Okay, let me connect to Wi-Fi again. So for some reason, this is not showing in the screen. Let me try to connect again. Meanwhile, you guys can tell me if you have any confusion regarding how we are defining these unit vectors.
Sir,
Yes, tell me.
so these all topics in book
Yes, all
classical dynamics,
topics
sir.
are there in the book. Yes,
Classical dynamic only.
in this PY111 book. Yes, all the topics are there. Okay, now it should work. You should see my notebook. Is it available now?
Yes, sir.
Okay. Okay, so where we stopped, we defined the scale factors. Okay. Now the unit vectors E rho cap, this will be del R by del rho divided by mod of del R by del rho, right? So del R by del rho, we have already done the derivative here. That is I cap cos phi plus j cap sin phi. And the scale factor is 1. So unit vectors is basically just I cap cos phi plus j cap sin phi. Similarly, E phi cap, that is del R by del phi and mod of del R by del phi. So this also, then again you can see this will be minus I cap sin phi plus j cap cos phi. And similarly, E z cap, this will be del R by del z divided by mod of del R by del z. And this will again see this will be k cap. Okay. So this way you can find out the unit vectors for any coordinate system. If you find out the scale factors and do this partial derivative. Okay.
So,
Yes.
so what are the formulas that we have to keep in mind for exams? Like this is a very long thing. So what is the extract that we have to keep in mind?
These formulas are basic. This you have to remember. For example, how we are defining these unit vectors. This you have to remember. For example, H1, H2, H3. How to find this unit vector. This you have to remember.
Okay, sir.
These formulas for the unit vector. Formula for this unit vector and this expression for gradient of T, divergence of A, and curl of A, and grad square phi. This you have to remember. If you remember, it will be easier. Otherwise, you have to derive yourself during the exam. Okay. So
Okay, sir.
these are fundamental for that. These I told you that these are fundamental mathematical concept, and this you have to remember. There is no other way around. Okay.
And so derivatives will also be coming in exam.
So what you have to remember, basically you have to remember this part. Okay. So you have to remember that how we are writing this one. For example, what is the value of x in the cylindrical coordinate? Rho cos phi. If you know these values, then you can write this expression for r. So once you have this expression, then you can derive the unit vectors yourself, and then you can do all other mathematics in this coordinate system, right?
Okay, sir.
Okay, so this way you can derive the unit vectors. I gave you an example for cylindrical coordinate system. Similarly, you should do this unit vectors. You should find out unit vectors in the spherical coordinate system. Unit vectors E r cap, E theta cap, E phi cap. in spherical coordinate system. In spherical coordinate yourself. Okay. I can give you the final values. The scale factors will be HR, that will be 1, okay, and H theta, this will be R, and these are the scale factors, okay. But you should find out the expression for these unit vectors yourself using the same method, okay. Okay,
सर
yes.
ये जो आपने ऊपर में डिफाइन किया है dr/d
हम्म
ये इसमें तो आपने ऊपर लिखा है रो रो आएगा, ये H2
रो का मतलब
H2 रो आएगा ना, जो नीचे मॉड dr/d है वो तो
H2 is phi, H2 is not rho.
H5
H2 is phi.
ओके
See, these are the U1 is rho, U2 is phi, and U3 is Z. Okay. You can tell other way also. Then, as I told you in the last class, this will be left-handed coordinate system. Okay. This U1 is rho, H2, U2 is phi, and U3 is Z. Okay. Okay. Now you can also define this infinitesimal displacement. As I told you that infinitesimal displacement. This will be in the Cartesian system. We told you that this is R is basically dx I cap plus dy j cap plus dz k cap. But in the curvilinear coordinate system, this R, this is a function of u1, u2, and u3. Okay. So our dr, this will be del R by del u1 du1 plus del R by del u2 du2 plus del R by del u3 du3. Okay. So del R by del u1, this is h1 u1 cap. This you can check. Okay. This is the definition, u1 cap. Similarly, del R by del u2, that is e2 cap. du2 e2 cap, and this is from our definition of del R by del u1. Where we have defined this one? Where you have defined here. So you can see del R by del u1, that is h1 u1 cap. Okay. So and this you can write also h3 du3 e3 cap. Okay. So this is the expression for infinitesimal displacement. Now, for example, in cylindrical system, again in cylindrical system, you know h1 equals to h rho, that is 1, h2 equal to h5, this is equal to rho, h3 equal to hz equal to 1. So you can say in cylindrical system, dr, this will be h1 is I, this will be u1, this will be e rho cap, d rho plus h2, that is rho. So this will be rho d phi e phi cap plus along z direction, this is 1. So this will be e z cap dz. And this you can check from our previous class also. This was the expression for the infinitesimal displacement in the cylindrical coordinate. Similarly, you can do this same thing. Find out same thing in the spherical polar coordinate. In spherical polar coordinate, what will be the value for infinitesimal displacement if you know h1, h2, and h3? Okay. And then what will be arc length? Arc length, we told you that dss square, that is basically dr dot dr, right? So this will be h1 du1 square plus h2 du2 square plus h3 du3 square. Okay. And then again, if you know h1, h2, h3, then you can just replace these values and get the arc length in any coordinate system. Okay. Also, now we also want to find out this expression for the gradient. I'll give you the final expression for the gradient. Gradient, what you can, this formula for gradient of t in this system is E1 cap by H1 del T del U1 plus E2 cap by H2 del 2 del U2 plus E3 cap by H3 del 2 del U3. And again, if you know these values of H1, H2, H3, then you can get the gradient of this formula for gradient in any coordinate system, cylindrical coordinate system or spherical polar coordinate system. So basically, you need to know the scale factors and how to define the unit vectors in different coordinate system. Similarly, the expression for divergence, this divergence, this will be divergence of A. This you can write as 1 by H1 3 del U1 H2 H3 A1 plus del U2 of H3 H1 A2 plus del U3 of H1 H2 A3. So how you will remember that in the denominator you have all the scale factors, and when you do the partial derivative, if you do the partial derivative for A1, then H2 or the other two scale factors appears in the expression H2 H3. Similarly for A2 it is associated with H3 and H1. Similarly for A3 it is associated with H1 and H2. This way you can try to remember this expression. And finally, you can also write curl. How this curl, you can derive all this expression, but I don't want to go into the derivation because then this derivation will be much longer. But you guys can do it yourself. How you can derive this expression. If you find it's difficult to remember, then you can derive. This will be H1, H2, H3, and this will be H1, E1 cap, H2, E2 cap, H3, E3 cap, del U1, del U2, del U3, and this will be again H1 A1, H2 A2, H3 A3. Okay, this will be the expression for the curl. So in the exam, what we can ask, for example, we can ask you that let's say we'll give a particular coordinate system, and then we'll ask you that okay, you find out the expression for the scale factors or the expression for the unit vectors or the expression for this gradient, divergence or the curl. This type of question you can expect. Okay. So for your convenience, I can write down these formulas once again. What are these basic formulas for the infinitesimal displacement or this gradient vectors? These I can write again so that you can recap. Okay. So let me write again. So this infinitesimal displacement so in the Cartesian system, in the X, Y, Z system, this we write as dr. This is basically I cap dx plus j cap dy plus k cap dz, right? In the r theta phi coordinate, okay, let me start with the unit vectors. So then it will be much clear. So unit vectors So in the x, y, z system, your unit vectors are I cap, j cap, and k cap. In the spherical polar coordinate, these unit vectors are E r cap, E theta cap, E phi cap. Okay, there's one thing in my note, you will see that sometimes I wrote this as E r cap, E theta cap, and E phi cap. Alternatively, sometimes I wrote this as r cap, theta cap, phi cap. Okay, this also you can write. Okay. And similarly for this cylindrical coordinate system, this is rho, phi, and z. Your unit vectors are E rho cap, E phi cap, and E z cap. And in my note, again, you will see sometimes I wrote this as rho cap, phi cap, and z cap. These are same thing. Only thing is that you need to define. You are defining in terms of E r cap, E theta cap, E phi cap, or R theta phi. Similarly, in cylinder, it is E rho, E phi, E z, or rho cap, phi cap, z cap. Okay. So in the spherical polar coordinate, this you can write dr. This will be E r cap dr plus E theta cap. This I told you, this will be R d theta plus E phi cap r sine theta d phi. In the cylindrical coordinate system, this will be rho phi z, and this expression for dr will be E rho cap d rho plus E phi cap rho d phi plus E z cap dz. And in general system, U1, U2, U3, in any general system, this you can write U1 cap H1 du1 plus E2 cap H2 du2 plus E3 cap H3 du3. Okay. So as you can see, all these are composed of these unit vectors, and their infinitesimal derivative dr, d theta, d phi along this defined direction. Only thing is the scale factors are different in all these formulas. Formulas for H1, H2, H3, these are different, and those values you have to remember. Okay. Similarly, this expression for this operator also we can write. Let's start. This operator for this gradient or this del operator. Del operator in the Cartesian coordinate, this was I cap del del x plus j cap del del y plus k cap del del z. In the r theta phi coordinate, this del operator, this will be E r cap del del r plus E theta cap 1 by r del del theta plus E phi cap 1 by r sine theta del del phi. In the rho phi z coordinate system, this del operator will be E rho cap del del rho plus E phi cap 1 by rho del del phi plus E z cap del del z. Or if you write in general coordinate system u1, u2, u3, then this del operator will be E1 cap by H1 del U1 plus E2 cap by H2 del U2 plus E3 cap by H3 del U3. So once you know the del operator, then you can find out all other expression for this gradient, divergence, and curl. Once you know the unit vectors, these unit vectors and this del operator, then you can find out the expression for all other coordinates. And what are the unit vectors? General formula for unit vectors, I told you that del r by del u1, this will be h1 e1 cap. Del r by del u2, this will be h2 e2 cap. And del r by del u3, this will be h3 e3 cap. Okay. Okay, so do you guys have any questions so far? Do you guys have any question? You guys can unmute and tell me if you have any question at this point. No question from anyone? Okay. So if not, then we will end this coordinate system here today. Okay. So I'll give you now. Permission is given. If you have question, you can ask me. Permission is given to unmute. Okay. So if you guys have question, you can unmute and ask me.
Sir, can we get some questions related to the topic that you taught today?
Yes, I'll send you both assignment and tutorial regarding this lecture. Generally, I try to give you this tutorial and assignment at the end of the week, nearly end of the week, either Thursday or Friday.
Okay, sir.
But within this lecture also, I told you what to do. For example, I told you to find out this expression for this gradient, divergence, and curl in different coordinate system and the scale factors. Like what will be the scale factor HR, H theta, and H phi in spherical polar coordinate. This type of example you should do. Okay, so you guys do this work. You guys do this work, this spherical polar coordinate. Spherical polar. I have shown example for cylindrical coordinate system, right? So you guys should work out the spherical polar coordinate. Okay. This expression for HR, H theta, H phi, and ER cap, E theta cap, and E phi cap. This you guys should work out at home. I have solved the cylindrical system. You guys should solve the spherical polar coordinate. This you guys solve.
Okay, sir.
Okay. Any other question? So if there is no question, then we'll end this lecture on coordinate system. Next day, we will start rotating reference frame. Okay. So far, we have dealt with stationary coordinate system. Okay. But sometimes this reference frame, they can be moving. So we will start with this moving coordinate system, inertial and non-inertial reference frames. And we'll see what happens. We will derive the expression for Coriolis force and work out the problem of rotating reference frame. Okay. Okay, so if there's no question, then let's end here. Okay. So I have stopped this one. Okay, let's end here and we'll meet again tomorrow. Okay. Okay, then bye.
Okay, sir. Thank you.
Recording stopped.